Recording in progress.
Number 23, this is a question in Form 4, calculus, application of differentiation. Now you're given displacement x meters of a particle moving along a straight line after t seconds is given by this. That is x squared is equal to t cubed over 3 minus 3t squared plus 9. Determine the value of t when the particle is momentarily retraced. So when the particle is momentarily at rest, it means that it is not moving, so meaning that velocity is equals to 0. Now, when the moment you see the question of application of differentiation or integration, that subtopic is known as kinematics. And in paper 1, it will be tested on differentiation. And in paper 2, it will be tested on differentiation and integration or integration. So for this one, you just need to write SVA. So S standing for displacement, and V is for velocity, and A is for acceleration. So if you want to find, if you are given the equation of displacement and you want to find velocity or acceleration, meaning that you're going to move down, for this one you're going to differentiate. If you're given the equation of acceleration and you are required to find velocity or displacement, or we are given the equation of velocity and you are required to find the equation of displacement, meaning that you're going to move up, for this one, you're going to integrate. Now this one moving up, that is paper 2, moving down, that is paper 1. So for this one now it is, you're moving down. So, and because the velocity is equals to 0, when the particle is at rest, V is equals to 0. Now, when you look at this equation, this is an equation of displacement. So meaning that for us to get V, you're supposed to integrate. And here you should be very careful because this equation, it has started with X, but not S. So in your differentiation, you're supposed to write the X over the T because you're integrating X with respect to T. So this one will be 3 over 3 T squared minus 6T. Of course, this one, the constant will be 0. So, and then you're given that, now this one is the same as the X, the T is the same as V. So you have V is equals to T squared minus 6T. Now, the value of T when V is equals to 0, you're going to substitute where you have V, you put 0. You're going to have T squared minus 6T is equals to 0. Of course, T is common, so put T outside the bracket. You're going to have T minus 6 is equals to 0. So meaning that T is equals to 0 or T is equals to 6 because of this, because of T minus 6 is equals to 0. So we take 6 to the other side, we're going to get T is equals to 6. So you have two values, the values of T. So T is equals to 0 and T is equals to 6. For number Roman 2, the value of displacement X meters by the time the particle comes to rest, the values. So remember the first one, it was when T was 0. So when T is equals to 0, then X is equals to, this one you substitute in the original equation, given up there. So we're going to substitute, so that will be 0 over 3 minus 3 divided by 0 plus 9. So when T is equals to 0, X was equal to 9 meters. And when T is equals to 6, substitutes. We're going to have x is equals to 6 cubed over 3 minus 3, 6 squared plus 9. So work out that one. Divide by 3 minus 3 plus 9. Going to get it as negative 27. And reason because they're talking about displacement, and displacement is a vector quantity. So that is a negative 27 meters. Determine the value of t when the velocity of the particle is negative 5 meters per second. So when velocity, so you have v is equals to t squared minus 60. But now you ask now to find the value of t when velocity is negative. So you have v, will substitute with negative. So we're going to have t squared minus 16 is equals to negative 5. So that would be t squared minus 16 plus 5 is equals to 0. Now this one is quadratic. So you have t is equals to 6 plus or minus the root of that 6 minus 20 over 2. So we're going to have t is equals to 6 plus or minus. So this one will be 16. So that is 4 over 2. We're going to have two values. T is equals to 10 over 2. That is 5 seconds. Or t is equals to, that is 6 minus 4. That is negative 6 minus 4. That is 1 second. So you have t is equals to 5 or t is equals to 1 second. Number C, determine the acceleration of a particle at t is equals to 2. So you have a equation of v is equals to t squared minus 60. So you want now to get acceleration. So meaning that you're supposed to differentiate this one again. So dv over dt is equals to 2t minus 6. So substitutes. So at t is equals to 2, then acceleration will be equal to 2 times 2 minus 6. So acceleration will be equal to 4 minus 6. So we're going to find acceleration as negative 2. Acceleration is equals to negative 2 meters per square second.